Hi everybody, this is Taylor from ATAGO here in Japan. Thank you for joining me today for our webinar. We're going to be talking about cutting fluid management. For those of you that are watching live, please feel free to stick around and put your questions in the chat box, and then I can answer them as we go throughout the presentation. For those of you that are watching afterwards, if you do have any questions, just feel free to shoot us a quick email, and we'll be showing that email address as well, and we can answer you that way. So today's style is going to be presentation, but I also have some videos to show you as well for a few of the different instruments that you can use for cutting fluid management. For example, we have our new test fluid kit MJ that features a couple of our instruments right in here. So that will be in the video, and then we have some of our inline refractometers. So we have a lot of information that I'm going to go over in pretty great detail. So let's go ahead and get started here. And like I said, go ahead and put your questions in the chat box when you're ready. Okay. So, guide to cutting fluid concentration management. We'll be going over some handheld units called the PAL-102S for cutting oil, and then the PAL-PH, which is a handheld pH meter. And then for inline models, we'll be doing CM base beta and CM base alpha, and those will be inline refractometers. So for topics covered, just in general, cutting fluid management, why do it, what's concentration control, what's pH control. Our demo videos will show how to measure, and then for the inline refractometers, it will be how to install. So cutting oil concentration management. So why you should be doing it, if you're not familiar already, it's best for your machines to have the proper concentration of cutting oil. If you have your cutting oil too low or too high, then that's going to create different issues for your machine, also for your workers, also for cost. When you get cutting oil, it's usually in a concentrate, and you have to dilute that with some type of water and then run that through your system. And then depending on how you're running it, the concentration may change at different times. So you're going to have to keep checking the concentration at different points. So let's talk about if concentration of cutting oil is too low. So you can see I have a few things listed on the left there, like odor, corrosion. Those are bad things, but what I want to focus on is more the short tool life and the short oil lifespan, as well as quality issues. I think those are the three main ones that are going to be related to money. So if you have short tool life, that means you're buying your tools more often, which is costing you more money. If you have short oil lifespan, that means that you're using your oil too quickly and you're buying more oil and you're spending more time replacing it. So time also equals money. And then for quality issues, that's about the parts that you're making. So if you are running too low of a concentration of cutting oil, then you're going to have some maybe malformed parts that come out. So it's best to not have the concentration too low. On the flip side, if your concentration is too high, you have things like foaming going on, which is not very fun. You have skin issues that could happen with the workers if they're coming in contact with the cutting oil and it's really high concentration. They might get like dermatitis or just itchiness, irritation going on. More related to the money side of it, there's higher oil consumption. So if you're using too high of a concentration of oil, so there's too much of the cutting oil in the mixture, then you're using more and you're buying it even more. So you're spending a lot of money when you don't have to be using that much oil. Also, quality issues with your tools. If your machine is running with a cutting fluid at too high of concentration, then the tools might not come out the way that they're supposed to as well. So for when you should be checking the cutting oil concentration, there's one first step where you're going to make the diluted solution of cutting oil with the concentrate into water. So that will be your kind of first checkpoint to check the concentration with a refractometer. And then second is during the actual machine cutting process. So there are some factors that are going to change the concentration, like evaporation and usage. So you're going to want to monitor the concentration level throughout the actual cutting when the machine's running. And then also another point will be oil replenishment. So when you have your current diluted solution in your machine, and then you have to add some more diluted solution to bring it back up to the right concentration, you're going to want to do a final check with your refractometer to make sure that you're running at the right concentration for your final solution. So why should you choose ATAGO's PAL-102S? Well, you'll see in the demo video that it's really, really easy to use, but some other things for you to consider over maybe some other manufacturers is that ATAGO, all of our products are made in Japan. They have really great Japanese quality, been in the business for over 80 years. When you purchase, you get a 2-year warranty after registering it. Also, it's just made with very high quality materials. The body is resistant to, they're called amines in cutting oil. And then we have really good supportive aftercare service, or if you need application information or how to use your instrument or something is broken. We have offices all over the world. We have really great distributors. We have service centers. And then as well, for more of a function aspect, we do have a new feature called NFC, which is near field communication. So that's actually transferring the data from your handheld refractometer to your phone or to a computer that has an NFC reader hooked up. So those are just a couple of reasons that you should go with the PAL-102S. So then let's also talk about pH. I have 2 pH meters here. On the left is our PAL pH, which is more like the PAL-102S, kind of same style. And then on the right, I have the DPH2, which is a more dip style refractometer, or pH meter, sorry. So when you are picking a pH meter, it's better to go with the PAL pH because it's more durable, it's easier to clean, it's going to last you longer. It has the NFC feature for data output. The KLC in the inside of the electrode is also non-consumable, so it's really just a higher quality, more durable, easier to use instrument than your typical dip style pH meter. And then in general, some reasons that you should be measuring the pH of cutting oil is to have better emulsion stability, avoid skin issues, and avoiding corrosion, rusting, and discoloration. So maybe your cutting fluid has the concentration level on point, like maybe you're already checking with a refractometer, but you should be checking the pH as well, because even if your concentration is at the right level, pH might be off and you may need to use like a pH stabilizer or something to make sure that your machine is running efficiently in terms of pH as well. So concentration management is just one aspect, pH management is another aspect. So what I'm highlighting here today is our fluid test kit MJ. This is both the PAL-102S and the PAL pH in one easy to carry case. You can purchase them separately, but you know, if you want to kind of have them always in the same place, be able to carry it around with you, then the fluid test kit MJ is a good way to go. Just wanted to note that you do get 3 calibration solutions with the test kit that you'll use with the PAL pH. Depending on what area you live in, you might want to get the different types of solutions we offer. So some parts of the world need 4, 6, and 9 for their calibration standard solutions, and some parts of the world need 4, 7, and 10. So you can get both of them very easily, so you don't have to worry about that. Okay, so we're going to jump into our video so you can kind of just see how the PAL-102S and the PAL-PH work. It's very easy to get out of the case. What you're going to want to do is get some type of like pipette or even a plastic spoon. Just avoid anything metal. Some people just dip it right in there as well because it's pretty resistant and easy to clean. Put it on, press start, and then boom, you get your measurement, and that's it. You'll want to clean it off with some water afterwards and a tissue, and then that's it. Same thing with pH, same concept, just put enough on there to cover the electrode, press start, and then you have your measurement. And that's really it. It's super, super easy. So we know how to measure on the PAL-102S now as for a refractometer, but I think we should talk a little bit about what a refractometer is and what that value means. So a refractometer in general measures the total concentration of a solution, and that measures in what we call the Brix scale, and that can really be used for any type of sample out there in the world. The Brix scale is based on refractive index, and I don't want to go too much into it, but what you need to know is that the Brix scale, or the measurement on the refractometer, is not actually equal to the actual concentration. So if you get 10% on a refractometer as your reading, it doesn't mean that your cutting oil is 10% concentration. So what you have to do is actually convert that Brix percent to the actual concentration value. And it's not really hard, and I will show you here how you can easily do that. So the easiest way for finding your conversion factor is to just look in the specifications of the cutting oil brand that you're using. So you see I have a green star on the slide there, and you can see that this manufacturer put different concentration values at different ratios, and then put what the refractometer reading is for the cutting oil concentration at that ratio and concentration percentage. So then underneath the table, they did all the math and everything, and underneath the table they say that the refractometer factor is 1.47. So to find the actual concentration, you take your factor and you multiply it by the refractometer reading. So in this case, this manufacturer is saying that when you measure with the refractometer, then just multiply it by 1.47, and that will give you your actual concentration level. So it's not too hard, especially if you have this type of cutting oil that has a spec sheet that lays it out there for you like that. Now, there is a different way to find your conversion factor, slightly harder but still pretty easy. If you happen to be using a cutting oil that you don't have the spec sheet for, or that manufacturer somehow has never measured with the refractometer, you can easily figure it out yourself. So for this example, we will be taking a concentrate, which is 10 grams, mixing it with 90 grams of water, and then making a 10% solution. If we measure that 10% solution on our PAL-102S, in this example, it's going to say 4% Brix. So what we need to do now is find our conversion factor. So what are we going to multiply the refractometer reading by? So the formula below is the solution percentage divided by the refractometer reading. So we already made our solution, which is 10%, and then we will divide that by the refractometer reading, which is 4%, and that gives us a conversion factor of 2.5. So if we're going to calculate our actual concentration, then we're going to take 2.5 as the factor, multiply it by our refractometer reading, which is 4, and then our actual concentration is 10%. So you can use that actual concentration formula down there, and you can measure on a refractometer, maybe it says 8, and then you will multiply that by 2.5, and then you'll get your actual concentration percent. So once you find that factor, so 2.5, then you can continue using that from then on, just multiplying everything by 2.5 after you measure it. So it's pretty simple. So you might be thinking, okay, I don't want to do math every single time that I measure with my refractometer. And that's okay, because ATAGO is one step ahead of you and already put a feature on there to help you with that. So once you've found your conversion factor, there's a feature called the offset feature. And that's where you program the conversion factor into the PAL-102S, and then it automatically displays your actual concentration measurements. We're going to have a separate video that will come out later this week that will go into very detailed aspects of the PAL-102S, like zero setting, measurement, and then also programming this offset feature. So you'll want to check that out when we release it later. But I'll just go over a quick explanation below. So let's use 2.5 from our last example that we did, because I don't know if you guys remember from your grade school days, but there's the formula y equals ax plus b, which is like a linear correlation. That's the formula that the offset feature uses. So you can see that y equals the actual concentration, x equals the PAL-102S reading, and then a is the coefficient or your conversion factor, which is multiplication. You can ignore b because you will not need to use that. So if we use our last example, we know that our conversion factor is 2.5. So when we go into the offset feature on the PAL-102S, we're just going to change the x value, which is, back up, the a value, which is the coefficient. So x is going to be read by the refractometer, but you're going to put in the coefficient. And then after it's programmed in, the PAL-102S will do everything for you and then just display the final result, which will be your actual concentration. So this feature is so handy because all you have to do is find your conversion factor once, either by doing some math or just by looking at the spec sheet of your cutting oil, and then programming that into the PAL-102S, and then it just does the math for you and pops out the final concentration. So I really recommend, if you're a PAL-102S user, to use this feature because it's so easy. And once you program it in, it's going to stay there until you take it off. So you don't have to worry about it after that. Okay, so we're going to move on to inline refractometers, but I'm going to do a quick question check. Nothing? Okay, perfect. That means that we can move on. Okay, so let's talk about inline refractometers. ATAGO's been looking ahead into the IoT era, so that just basically means that the world is moving towards automation, kind of reducing the amount that people have to do manually and making things more automated and easier on people. So ATAGO developed inline refractometers that are compact and can be installed anywhere. So there's a list of features right there. I'm just going to brush over them a little bit. But basically the concept of an inline refractometer is to install it in, and then it's going to continuously monitor the changes in concentration of your cutting oil. And it's going to be continuous, so that means it's real time. So if you get a model that has data output, you can actually have that data outputted to a PLC system or a computer. You can find out the temperature as well. So instead of looking at the display of the instrument, you can actually have that go to your computer or another display, so that you can not always have to be right next to the machine to know the concentration value. Also, people have different programs that they use to set up alarms or whatnot, so if their cutting oil goes outside of spec, then they know right away. So those are the main benefits for an inline refractometer, is just reducing manpower, making things automated, having the data output, and you're going to have a lot quicker of a response time to any issues. So the first one that we have is CM base beta. So I'll show you a quick video of what this looks like when you're actually installing it. But the concept of the CM base beta is that it is an immersion style. It has a pretty wide range. Usually cutting oil doesn't really go over like 10 or 15%. So you're definitely covered. It's a pretty standard accuracy and temperature compensation range as well. You can choose between having the data output as 4 to 20 milliamp, another word for that is recorder output, or RS-232C. So it's a pretty easy instrument and very introductory when it comes to our inline refractometers. So let's get the CM base beta video up here. So this model is more designed for an open style tank. You can kind of see that there is a hook on it, so that when you hook it on the side of the tank, the immersed part is going to go directly into the liquid. You can see that the sensor is on the bottom. This is the cable that you'll hook up, which is going to supply both the power, but then also the data output for the instrument. So once you have it all secure, you just very easily hook it on the side where you want it. So I do want to recommend that you don't put it near any type of agitator, because there might be too many vibrations going on with the instrument. Also, let's see if we can go back. Also, if you have a particularly dirty cutting oil tank, like sometimes it gets like a lot of tramp oil in it or mucky, I would recommend to stay away from those areas where that dirt tends to collect and try to find a cleaner spot of the tank. Our tank is really clean, actually, so we don't really have that issue there. But if you are finding that your oil tends to become pretty dirty after a while, then just try to avoid those kind of spots. And then once you add the power, it will just continuously start measuring. So that was CM base beta. Like I said, it's the most introductory model, very easy to use and install. Another point I would like to point out would be when you're installing this model, I know it's really tempting to put it completely horizontal into the tank, but the hook was actually designed for it to go more at an angle. The reason for that is if you put it completely vertical, then you could get an air bubble up under where the glass prism is. So just try to do your best to make sure that when you're installing it, it's at the proper angle. Okay, so next we have CM base alpha. So this one is completely in line. I'll show you another video of how that's installed. But it's very similar to the CM base alpha, CM base beta in terms of specifications. So it has the same measurement range and accuracy. The data output, you can choose between RS-232C or 4 to 20 milliamp, which is a recorder output. Also just has one cable for both the power and for the data. So this one is just designed to be more in line and more integrated into the system compared to the CM base beta. And then I will show you why here in just a moment. Okay, so this type of machine is more closed, and where it's a lot better to have something that is in line. So you can see that the CM base alpha is hooked up with hoses in the back, and we have a special hose connector that you will get for that. And so this cutting oil is actually circulating through, going through the hoses, going across the glass sensor, and then going outward. So this is one where maybe you have a larger machine and you have a workstation maybe towards the front, and you want it to be easily seen by everybody, but maybe in the back is where the actual oil pan is, and it's not as accessible for everybody to go back there. There's not a lot of space to stick the CM base beta in there, so it makes a lot more sense to go with something more integrated like this. So those, in terms of inline refractometers for cutting oil, I would say that those are the two most basic introductory ones that we have. We do have some higher end inline refractometers that you can inquire about if you need maybe higher accuracy or whatnot, but I would say that most people will tend to go with either CM base alpha or CM base beta. Okay, perfect. So let's move on a little bit here. Just another example. So this is actually a glass grinding machine where we make our prisms. So just so you can kind of see the CM base alpha a little bit more and the hose connector, I just wanted to show this one real quick. Okay, perfect. Okay, so that's really all I have in terms of presentation and videos and whatnot. I just wanted to kind of dive in a little bit deeper into the application of managing cutting fluid with ATAGO instruments. Do we have any questions? No. Okay, perfect. So those of you that are watching this webinar after the fact, if you do have questions, please reach out to us. We're more than happy to help. One thing I do want to mention is along with the video that's coming about the PAL-102S, we call it like an instructional video, we do also have a factory cutting oil tour video coming out as well, where I kind of walk around, and it's the same footage that I was showing before, but kind of goes into our factory and how we're using them and why we're using them at certain points. So please feel free to check out that video as well if you have some time. Okay, well, without further ado, I will end this. Thank you for watching today, and I hope you have a good rest of your day. All right, bye-bye.